All right, so for this video, we're going to talk about initial conditions. Initial conditions, right, are when we take the antiderivative or integral, and we always end up with that constant of integration, that plus c at the end. Right, now we're going to go back through and find the actual c values to get an exact equation, not just our generic equation. So before we start, we'd like to thank our corporate sponsor, Sticky Feet Reptiles, stickyfeetreptiles.com. The steps for finding the initial condition, just a quick review. When you want to find the initial condition, you first want to just take the antiderivative, right? Integrate the function that you're given. And after you do that, substitute in the values they will give you for x and y, solve for your c, and then write the particular equation with c substituted back in. If you're given the second derivative, you'll have to do that twice in order to get back to the original function f of x. So we'll start off here with an easy one. It says we want to find the particular solution that satisfies the equation, and they gave us f prime of x equals 6x and f of 0 equals 8. So they gave us that xy value along with the equation. So let's go ahead and take a look at that one. So if we start, right, our step number one says we have to take that 6x and we have to integrate it. So when I come here from the original 6x, if I integrate it with respect to x, I add 1 to the exponent and divide by that same exponent. So that becomes 6x squared over 2, which we know as just simplified 3x squared. Whenever I take the integral, I have to add that constant of integration, so I have that plus c at the end. Now, the new part to this, right, they gave us this initial condition up here. They said f of 0 equals 8. So of course the 0 will go in for x, the 8 will go in for the function or our y, and we'll solve for the c. So instead of x squared, I put 3 times 0 squared, our new x value, plus our constant is equal to 8. This, of course, is all 0, and then we just get c equals 8. So my last step, if I rewrite the equation for this particular solution, it's f of x equals 3x squared plus 8. So that one was pretty basic. Let's go ahead and look at a second example. This one includes some trig functions, plus it gets a little more complicated because they gave us the second derivative. So the original problem for this one, they gave us the second derivative was equal to sine x, and they gave us two conditions here. They said f prime of 0 is 1, and f of 0 is 6. So the first step, I want to find just the integral of sine x. So I take the integral of sine x dx. Of course, our sine rule, we have the integral of sine is negative cosine. And because I have two derivatives I'm going to be taking, I'm going to call this C1 just to distinguish it, right? So it's just a constant, but because I'm going to have two different ones, I'll put C1 just to make sure we know the difference. So my first condition was that f prime of 0 equals 1. So I'll take that first derivative, because when I integrate the second derivative, I get back to the first derivative. Put a 0 in for x, set it equal to 1. Well, cosine of 0 is 1. 1 times negative 1 is negative 1. So negative 1 plus c equals 1. Add the 1 over, and I get my first constant equal to 2. That means my first derivative is negative cosine x plus 2. So instead of c, I put plus 2. Since that's only my first derivative, I have to integrate again to get back to the original function. So I take the integral of negative cosine plus 2 dx. And then when I take the integral of f prime, I get back to just the original f of x. So f of x is equal to negative sine plus 2x plus another constant of integration, different from that first one perhaps, so I called it c2. Because our initial condition here, they gave us f of 0 is 6. I put a 0 in for my x's, set it equal to 6. So sine of 0 is 0. 2 times 0 is 0. So c2 is just equal to 6. So in the final, I take f of x equals negative sine x plus 2x. Instead of c, I put my second constant in of 6. So that's finding initial conditions or particular solutions with integrals. I hope that was helpful. Make sure you like, subscribe, and let a comment if you want to see something different. Thank you.